So today we're going to be looking at linear equations, and it's important to know that linear equations are one of many topics that make up the bigger, broader topic of algebra on the digital SAT. And overall, the algebra topics combined comprise about 35% of the questions on the digital SAT. So what that means is that although linear equations won't make up the full 35%, they'll be one of the topics of many topics that altogether will make up 35% of your test. So they're very important to know. They're going to be a crucial part. They're basically a building block for like all the other math that you need to know. And then College Board tells you that you are going to have to know three things about linear equations, which is analyzing them, which refers to things like graphs, intercepts, slope, that sort of thing. Solving, which is literally just solving for x or y values or different terms of x or y, like it might ask what's x plus y given a certain equation or something. And then creating, which is those are the more sort of like word problems where they'll basically give you a bunch of words describing a scenario and you'll be asked to create a linear equation representing or modeling the situation. So let's look at the first part, which you'll have to know, which is analyzing. Now, like I said, analyzing is mostly just logical reasoning, crucial thinking skills, and then being able to tell certain features about graphs and linear equations. So we're going to look at two problems here. This first one says, if 4x plus 2 equals 12, what is the value of 16x plus 8? Now, at first, this might look like a simple solving one because we're given an equation that we can solve for x, and then we're given another equation that we're supposed to give the value of. Now, that is one way to do it, but my goal here is to teach you the fastest way to do things. And in this case, I'll show you two different ways to solve it. I'll show you the slower way and then the faster way. And you'll see how using the faster way, you're actually using analysis and logical reasoning more than actually just being able to plug in and solve for a value. So if we use the first method, which is the slightly slower one, but it'll never let you down if you always want to try it, is to just solve for the first one. So we have 4x plus 2 equals 12. So if we're just going to go ahead and solve for x, we're going to subtract 2 from both sides so that the equality stays an equality. You have to do the same thing to both sides. So we're left with 4x equals 12 minus 2 is 10. And then if we divide both sides by 4, we're left with x equals 10 fourths or 5 halves. Now we're going to plug it into this one because we're asked the value of this. And if we plug in 5 halves, we'll have 16, remember x is 5 halves, plus 8. And then if we go ahead and distribute the 16 to the 5 halves, what you end up with is 16 times 5 over 2. And what you can do is just divide the 2 from the 16. So 16 times 5 over 2 is the same as just 8 times 5 because you can break it up. Instead of 16 times 5 over 2, since you're multiplying these two things, you can actually write this like 16 over 2 times 5. And so when you do that, this cancels out to an 8, and we're left with just 8 times 5 plus 8, which ultimately equals 48. So that's one way to get our answer, which in this case it'll be B. But let me show you the faster method. So the faster method involves using logical reasoning, and instead of just solving for the x and doing all of this actual math over here, what we can say is, well, if 4x plus 2 equals 12, and we're solving for 16x plus 8, then what we can do is just take this whole thing and multiply it by 4. Now when we do that, what's going to happen is we distribute the 4, and it's interesting, you can actually do this to an equation. There can be an equal sign in there, and you can still multiply the 4 to everything. So the 4 goes to the 12, to the 2, and to the 4x. And then you'll see what happens is that this left side, the 4x plus 2, actually becomes 16x plus 8 because the 4x times 4 is 16x, and then the 2 times 4 is 8. And then all that we have to do now is distribute the 4 to the 12, and we can see that this is going to actually equal 48. And now all we had to do was this one step of recognizing that this is simply 4 times the value of this, so therefore this has 4 times the value of this. So that's another way that we can get the answer that's slightly faster, and that's using more analysis than just plugging it in and solving for x. Another way that they could ask you to analyze a linear equation is with something like this, where they give you a graph and you're asked to write an equation for it or recognize some sort of property about it. I'll show you how to do all those things in this one problem, so it'll be a little bit overkill, but you'll know how to find it, like find the matching equation through multiple different ways. So it says the graph of the linear function f is shown. Which of the following defines f? So there's a couple things you need to know to be able to recognize a graph or a linear equation. The first thing is slope, and the second thing is you can either use y-intercept or x-intercept. Usually y is easier, but in this case it looks like they want an x-intercept. So to find slope, all you're going to do is, I like to use the mnemonic device rise over run. That's just always been the one that stuck with me. And so all that means is you're going to write basically delta y over delta x, and delta just means like change in. So rise is the change in y, and y is the vertical direction, so that's going to be like rising or falling, so that's going to be up or down. And then the delta x is just going to be from left to right, and that just means the change in the x position. So if we look at the slope of this graph, which runs down this way, what we're going to see is we can just pick any 2 points we want for that are on the line, and then put in the change in y over the change in x. So for this one, it looks like this is a pretty good point right here, and then this is one right here. So the change in y between these 2 points is going to be how far up and down it moves. And then it's important to know that if it's up, it's going to be a positive value, and if it's down, it's going to be a negative value. So in this case, it goes down, so we know it's going to be a negative value. And exactly how much it goes down is 1, 2, 3, 4. So it's going to be negative 4. And then the delta x is just going to be left and right, so that's just going to be 1 in the positive direction, so it'll just be a positive 1. So from this, we know that the slope is negative 4 over 1, which is just negative 4. And we know that the equation for a line is going to be y equals mx plus b, where m is the slope and b is the y-intercept. So right off the bat, we already know that the slope is going to be negative 4. And so over here, when they write f of x, by the way, that's just another way to write y. We're just saying that y is a function of x, which means that as x changes, the y value changes. So therefore, that's just another way to say f of x, that y is a function of x. And so over here, if we just imagine that this is a y, then we know that it's going to be f of x, because that's how they're writing it, equals, then we know that the slope is negative 4, and then it's going to be times x. So right off the bat, we know that it can't be c or d, because we know that the slope is negative 4. Then what we have to do is pick a point that makes it easy for us to see what the y-intercept is going to be. Now, it should be pretty easy to tell that if this line were to continue up in this direction, and this is the y-axis, then it would hit it pretty high up. And so if we're looking at, if we're deciding between whether the y-intercept, which is this b, should be positive 2 or positive 8, it's pretty obvious that, this is going to be at 1, and then 2 would be here. So it's definitely going to go past 2. So it's most likely going to be 8. But if you really want to double check it, you can actually just pick any point on the line, plug in a value, and then see what you have to add to get the y value. So for instance, if we pick this point right here, and then we plug it into our equation, now we have y equals negative 4x plus b. Then if we plug in the y and x values for this, we'll get our b value. So for this point, the y value is 0, the negative 4 is constant, and then the x value right here is going to be 2, and then we have plus b. So when we fully expand this, what we're going to have is 0 equals negative 8 plus b, and from this we can tell that b has to be 8 to cancel out the negative 8 and go to 0. So in this case, b is going to be our answer. Now for solving linear equations, this is just going to be simply solving for x or some term of x. So for this one, it says, which of the following is the solution to the equation above? And when asked for a solution, that just means what does x equal? So in this one, we have square root of x plus 4 equals 12. Now what we want to do first is isolate the square root x on one side. So we're going to subtract 4 from both sides, get square root of x equals 8, and then what we're going to do is actually square both sides, and we're left with x equals 64, because 8 squared is 64. So this one is just as simple as isolating the x term and then solving so that it's just x by itself on one side. For this one, it says what value of x satisfies the equation above, and we have 5 times x minus 3 equals 10x plus 5. So for this one, you have to know the distributive property, which is that we have to distribute this 5 to everything in the parentheses, and once we do that, we'll have 5x minus 15 equals 10x plus 5, and then from here, we can just get x on one side and then solve for it. So we're going to subtract 5x from both sides. These cancel out, we're left with just negative 15 on this side, equals 10x minus 5x is just 5x, and then plus 5. Now we want the x by itself, so we're going to subtract 5 from both sides, and then this becomes 5x equals negative 15 minus 5 is negative 20. So therefore, when we divide both sides by 5, we can see that x equals negative 4. So the answer to this one is going to be A. Now the final way that the digital SAT can test your knowledge on linear equations is through creating your own linear equation through words or some sort of description they give you. So this first problem says, Jamila plans to invest $300 by buying shares of 2 different stocks. Stock A costs $5.62 per share and stock B costs $12.97 per share. Which equation represents the number of shares of these stocks Jamila can buy, where A is the number of stocks of stock A and B is the number of stocks of stock B? Assume there are no fees. So, if we want to find the total cost of something, then what we have to do is multiply the cost of 1 unit times the number of units, right? Because if you have, for instance, 1 orange costs you 50 cents, then we would plug in a 0.5 here, and then the number of oranges, say that we bought 3 oranges, then the total is going to be $1.50. And so when we're solving for the total cost of stock A and stock B, what we can see is that for stock A, the cost we already know is $5.62, so we're going to write 5.62. And then for the number, we're told that lowercase a is the number of shares of stock A. So we're going to multiply this by A. And then what we're going to do is, since we're looking for the total cost of A and B, we're going to add this for stock B. Now for stock B, the cost is $12.97, so we're going to plug that in. And then for the number of shares, we're told that that is represented by lowercase b, so we're going to put that in. Now this represents the total cost of all of the stock A and stock B. And we're told that she wants to invest $300 total. So what this means is that this has to equal $300 because we want her total expenses to be $300, but depending on the number of A and B stocks, she can break it up how she wants to. So now all we have to do is recognize which one matches this. And in this case, it looks like the answer is going to be C. Now for this second problem, it says, at a store, a coat originally priced at P dollars is on sale for T dollars, and the relationship between P and T is given in the equation above. What is P in terms of T? So when you're asked to find something in terms of something else, all that means is that the first thing that they tell you, so in this case, what is P in terms of T? We want P by itself on one side. So if we look at the equation that they already give us, we're given T in terms of P because T is isolated and then P has some other stuff attached to it. So in this case, since they're asking for P in terms of T, all that we want to do is get the P by itself. So if we have 0.8 essentially times P equals T, and we want this by itself, all that we have to do is divide both sides by 0.8, and then these two things cancel out, and we're left with P equals T over 0.8. Now what you'll see is that D matches the answer perfectly, but sometimes they'll write it in a different form. So for example, in this case, dividing by 0.8 is basically the same thing as dividing by 8/10. And so what they could do is they could do something like give you an answer such as 5t over 4, and then this would actually be the same, if we wrote p equals, this would be the same as this, because when you have t over 8 over 10, what you can do is rewrite it as t over 1 divided by 8 over 10, and then we just use keep change flip to say that that equals t over 1 times 10 over 8, which equals 10t over 8, which when simplified equals 5t over 4. So just keep in mind that they can put it in different terms that you might not be as familiar with, but just know that you can use the methods and skills that you already know when like solving for equations and stuff to find the right answer, but it might not always be in the exact form that you originally intended it to be.